In this section, we're moving on to the next piece of derivatives here. What we've done is we have so far done the basic differentiation rules. We've done the product rule where you have two things multiplied by each other, and we have the quotient rule where two things are divided by each other. With the chain rule, what's going to happen is we are dealing with things that are basically like a function within a function. So you may not fully see it at first, and this can be complicated, but what we're going to do is we're just going to show you a little bit about what the chain rule is, and then some examples, and then mostly we'll work on this stuff in class. So here's some examples where we don't need the chain rule, something like x squared plus 1. X squared plus 1 is very, very simple. When we take the derivative of that, it would just be y prime equals 2x. It's one simple function without anything added to it. Now this one right here, y equals the square root of x squared plus 1, the problem is that we have a function x squared plus 1 within a function which is a square root. So the basic rule that I tell people, and this makes things a whole lot easier, is we always want to work things from the outside in. So no matter what, we're still going to use the same properties we've already learned. We've already talked about doing things like the product rule and the quotient rule, but in the original basic differentiation rules, we said that we want everything to be a power. So our first goal here would still be to rewrite this as a power. So this will be x squared plus 1 to the 1/2 power. Now, here's the way that you would want to look at this. The outer function, I don't care about what's on the inside. The outer function is just parentheses to the 1/2 power. The derivative of that parentheses, don't worry about what's on the inside. The derivative of just this portion, this is what we call the outer. The derivative of that parentheses is going to be 1/2 times parentheses to the negative 1/2. I'm just doing the regular power rule, multiplying to the front and then subtracting the power by 1. What is in this parentheses is exactly the same thing that you started with. So now we go to the inner portion, and you'll see kind of how this ends up. The inner portion is x squared plus 1, which is, the derivative of that is 2x. When you write your full derivative, your y prime here, is just going to be these two things multiplied by each other. But remember, what goes in the parentheses what started in the parentheses. It does not change. The key thing about the outer is that whatever is inside will stay exactly the same as it was, because eventually we will be taking the derivative of what's in the inside and be multiplying it. So that means we will have 2x times 1/2 parentheses, and then we rewrite x squared plus 1, and then we have to the negative 1/2. Okay, and then again we can simplify this to be y prime equals, and then the 2 and the 1/2 will cancel out, so we have x on the outside, we have x squared plus 1 to the negative 1/2 on the inside. And again, we could move this to the bottom, but for time's sake, we're not going to. But we would move that to the bottom and put everything underneath the square root, just like it had started. So let's start on the next one. So that's the first one. The second one that we're going to look at, okay, is we have y equals the sine of x. Okay, so we look at y equals the sine of x. We know the derivative of that is just cosine of x. Okay, again, the problem is now we have y equals sine of 6x. So technically, we have two functions involved there. Now I get over here, x is still its own function, but what we're looking at here is our outer function will be the sine of whatever we have. So sine of parentheses, which then becomes the cosine of parentheses. I don't care what's on the inside, whatever's on the inside will stay. Now the inner portion of that function is 6x, which becomes 6. And then we multiply everything together. This will be on the outside. So the derivative just becomes y prime equals 6 times the cosine of whatever's in parentheses, in this case 6x. So that's the derivative there. Okay, the next function we're dealing with is 3x plus 2. Okay, so let's see how this one works. And use the back side of your paper if you need to. So we have 3x plus 2. The derivative of y equals 3x plus 2 is just 3. That's pretty easy. But here we have 3x plus 2 to the 5th power. So y equals 3x plus 2 to the 5th power. Okay, so what happens here is, again, think about your outer. Your outer function is just parentheses to the 5th power, which means the derivative of that will be 5 parentheses to the 4th power, and then the inner function is just what's on the inside, 3x plus 2, which the derivative of that is 3. Again, multiply everything together, leave whatever was in the parentheses to begin with the same, so therefore we have 5 times 3 is 15, parentheses, 3x plus 2 to the 4th power. So it's almost the same as the power rule from before, it's just that we have to make sure that we're doing derivative of the outside and derivative of the inside. Now these are some easier ones, but what we need to realize is that it can get a little bit more complicated, and we'll work on that a little bit more in class. What we're going to do is this one I want you to do on your own. Let's see if you can do that one on your own. It's a little bit trickier, but bring it to class. I just want to keep this video short. Bring that to class, and that's going to be kind of what our warm-up is and what we're dealing with. So try this one on your own, and then from there, bring that to class, and then let me know if you have questions. So hopefully this is a brief overview, and we will be working on this for a few days. So if there's been an Edmodo quiz assigned, take it. Other than that, I'll see you in class.